As for today, I'm really delighted to welcome Dr. John England to the University of Connecticut. John is Professor Emeritus in Earth and Atmospheric Sciences at the University of Alberta in Edmonton, Alberta, Canada. John is recognized for his 5-decade survey, so 5 decades, 50 years, and I'll try to bring this up in various different denominations, focused on unraveling the nature of environmental change from the Ice Age to the present across the Canadian Arctic archipelago, which is an area the size of Europe. But as John likes to point out, it's Europe with no roads. So his research, including 30 graduate theses, has included the reconstruction of ancient ice sheets, sea ice, and sea level changes, as well as lake and ocean sediment cores. He and his graduate students have significantly advanced our current knowledge on the Inuitian ice sheet, that is the continental ice sheet, which extended across the Canadian Arctic archipelago. During that half century of fieldwork, so 50 years, 5 decades, half a century, he has untangled the complex array of environmental changes that either drove or resulted from the behavior of this ice sheet, including how it shaped the landscape and influenced the global sea level. The integration of this work provides the necessary long-term perspective for the proper understanding of the Arctic and a warming world. John is a Fellow of the Royal Society of Canada. He was named one of Canada's 100 greatest explorers by the Canadian Geographic Society. He received the W. Garfield Weston Foundation Award for Lifetime Achievement in Northern Science and the Northern Science Award from Polar Knowledge Canada for his distinguished achievements and his substantial contribution to the North and, as John would emphasize, its people. Dr. England is a passionate advocate for increasing public awareness of the importance of Arctic environments and for the protection of the northern environment and northern science. He was instrumental in the creation of Canada's northernmost national park, Kinnear Park, if I got the pronunciation correct, on Ellesmere Island, which is in the Canadian Arctic. He's also involved with mentoring Indigenous students in the environment program at Aurora College in the Northwest Territories. He emphasizes that, as important as one scientific career might be, it is the friendships, adventures, and stories that impart the deeper meaning and growth that we are all called to share. When I invited John to participate in the Teale lecture series, he responded within hours, and saying that he was honored to be invited. I'm really delighted that he accepted to share his expertise, his experience and passion for northern environment, come and talk to us about the environmental change he has observed, address the substantial implications of this for northern Indigenous communities, reflect on his own career that spans the very interval of the Arctic amplification, the period during which the climate in the Arctic changed, and also reflect on the 19th century explorer that set the reference for much of his work. Please join me in welcoming John, whose talk is entitled In the Footsteps of Late 19th Century Explorers, Reconstructing Environmental Change Across the Canadian High Arctic.
Thank you, Bernard. And Bernard told me I had 45 minutes. But he didn't tell me he would take the first 10 minutes introducing me. But thank you. That was a generous introduction. And I really am honored to be here. It's immensely appreciative, especially in the lounge today, seeing the past posters for the Teale lectures, and really the very significant spectrum of people that have come to speak. And I think what I would have to say right at the very onset is that there's a really rich tradition of Arctic research in Canada. And when I speak, I also speak on behalf of many people whose observations I'm also citing here, and certainly a cadre of really talented, creative graduate students that I've been honored to have work with me. And I think I've really sense that again this morning, talking about the graduate and the undergraduate students here, that there's an enormous amount of creativity and energy that comes from those next generations of our scientists. So I thought I would start off just by emphasizing that the talk will be diverse. So we're looking here at the center of the Arctic Ocean, the North Pole, just for orientation, Greenland, and here we are down here at the margin of the Laurentide ice sheet. The stippled area is sea ice surrounded by the plain white is glaciers, and you can see this very large landmass, Russia and Alaska, Yukon, joining across what was called Beringia. And I show a few slides just to emphasize the diversity and the size of this place, as Bernard emphasized. This is a picture of me in 1978, and it says, "Store in a cool, dry place." That's a box top off an Eagle Brand box that Robert Peary left near the north coast of Ellesmere Island in the beginning of the 20th century. Glaciers, everyone expects to see those. Here's trees in the Arctic, way up on Axel Heiberg Island, 1,000 kilometers beyond tree line, 2 to 5 million years old. And then buried glacier ice that I'll also describe that has been sitting in the landscape for the last 13,000 years. So I'll try to touch on many of the themes related to these photographs. And first off, as you would appreciate, you can't show the Arctic without emphasizing the beauty and the serenity. It's one of the last places, I would say, part of the original Earth. It's almost like this diaphanous glow that used to cover the entire Earth is still preserved at the top of the planet. And walk through in this area to places no one's been before, and still finding, as you'll see, historic notes from the late 19th century that have never been revisited. So a very magical space, a place of silence and great environmental integrity still. And I really began as an undergraduate student going to Baffin Island, and it's that experience. I think we engage students in our labs, we engage students in our field work, and this is where the soul is ignited with curiosity and enthusiasm and interest. And this is in eastern Baffin Island, in the fjords, and glaciers there, really one of the most spectacular landscapes on the planet. I was very fortunate at the age of 18 to go up there and do glaciology, hydrology, geomorphology, glacial geology. And this is just scenes, and I emphasize here that, you know, the enormous change that has occurred in the span of my career, from aircraft and scientific methodologies right through to indigenous leadership. And all these things, I think, progressively are fused together in one inseparable experience. There's an old DC-3 on skis. There's a little piston-driven G2A helicopter where you move your camp and you tie everything on the float. There was nothing like an internal load. So it was a recipe for disaster so many times, and I could sit here and tell a couple of hours worth of aircraft stories, but that probably wouldn't be appropriate. But I also wanted to recognize that, yes, the late 19th century explorers opened up this area, but there's also a wealth of archaeological material on the landscape. And so the first arrivers didn't have canoe cross-country skis, but they did come by dog and sled and so on. The oldest archaeological sites are about 4,500 years old in the Arctic, and it's the Teale sites. Here's a fox trap with a fox skull still in it that are quite prevalent. There's a Teale house on eastern Ellesmere Island with the whalebone vertebrae as the furniture and flagstone and entry and so on. So everywhere I went, there was certainly very prominent evidence of the earliest peoples. Throughout the Arctic, wherever you go as well, there's the remnants of Arctic exploration. And so this is all about the various people that I've come across. And my PhD started in where Adolphus Greely in 1881-83 set up the US station for the first polar year at Fort Conger. And he was going there because Sir George Nares, about 6 years before him, 1875, had come into this area and wintered over with a ship. And many others visited this northern area. Peary, in his efforts to get to the North Pole, 1899, 1906. This is a signpost left by Peary at Cape Columbia, the northernmost part of Ellesmere Island. Otto Sverdrup, famous Norwegian explorer, traveled throughout this area. If you go up here, the names are British and American. If you come down here, they're Norwegian. The place names of the fjords and the bays, and really quite interesting. Many others in the Western Arctic, even earlier. Sir William Parry was the first to venture this far west through the Northwest Passage in 1818, and didn't quite get through. This is talking about sea ice later, this is the graveyard of multi-year sea ice in Arctic Canada. It's only recently opened up, and his ship was prevented from further progress, but he reached a place called Cape Bounty simply because he crossed the 110th meridian, and it was the British Admiralty had a reward of 10,000 pounds for the first ship to do that, get that far. McClure in 1850-54 looking for John Franklin, and his ship was lost here in Mercy Bay on Banks Island, and the ship was found only in 2012. And many, many others, McClintock, Stephenson. So everywhere I've gone, I've been reminded of the enormous record of exploration made by people long before. And the fear of being frozen in the winter led a lot of the early explorations to leave large prominent cairns on headlands facing expansive areas of the sea in case someone would be coming, hopefully to rescue them. That would alert people that they were in the area. And this is the HMS Discovery nearby on northern Ellesmere Island, overwintered in 1876. Two of their people died and are buried over on Hall Land, but their graves are at a little place called Fort Conger up on northeastern Ellesmere Island, where Greeley's house is located, and Peary dismantled that about 20 years after Greeley was there. Notes that I found were really exciting, and it was a great thrill to find notes from Sir George Nares. And all these things are serendipity, as they normally are. So way up on northern Ellesmere Island, here's Greenland. So we're up at about 82 degrees north. This is Fort Conger. There's the outline of Greeley's house, where he was in 1881-82. Off the coast is a little island, Bellot Island, and Ray Bradley, some of you will know from the University of Massachusetts, he and I went out to this island, and we climbed up on that mountain, and there was this beautiful cairn about the height of this room made of stone, and we sat down and opened up our tuna fish sandwiches and sat back and leaned against the cairn and looked across to Greenland, which literally disappeared over the curvature of the earth, the beautiful fjords. It was a splendid day, about 10, 12 degrees centigrade. And I noticed something at my foot, and it was the top of a brass cylinder, which was about over a foot long, and I pulled it out, and we pulled the top back, and all I could see, and we didn't want to open it further because it was a bit damp along the seam, but I could see March the 10th, 1876. So that was exceptional discovery there. And oddly, Greeley's men had climbed this island 6 years later for exercise, mandatory exercise going across the sea ice, and had never found that note. And it was interesting that when I got back, Sir George Nares, who left this from his ship, was under orders to leave a note on the north side of the cairn a certain distance. And this was almost due south, and the magnetic pole at that time, the North Magnetic Pole, if you were using a compass, was way in the southern part of the archipelago. So that's why it was there. So while I was doing my PhD as well, traveling around these fjords, around Fort Conger, I found a very long note from Greeley. So Adolphus Greeley, the U.S. expedition. This is his book, 3 Years of Arctic Service. And a fabulous read is about that expedition, and it's tragic escaped southward where they were under orders and had to overwinter down here. Only 6 of the 25 men survived. If you have a pen or a good memory, The Ghost of Cape Sabine by Leonard Guthridge is a really wonderful description and reconstruction of that. And Greeley was up there and explored much of northern Ellesmere Island. This is the national park that I was instrumental in creating, the northernmost park in Canada. And it's the Hazen Plateau, then the Grantland Mountains, and the largest lake in the high Arctic anywhere on the planet is there. A very spectacular area. And this is Greeley's house and the bedsteads. This is a garden. These are barrel hoops pulled off old barrels that were set up for a garden in 1881. The barrel hoops are still on the ground. And that was one of the notes. I saw this cairn as I flew out of the bay. We were going out with the DC-3 on skis, and we flew out about 100 kilometers to the coast opposite Greenland and worked our way back doing surveys. And when I flew out, I could catch a glimpse of this little cairn that separated 2 bays, 2 fjords. And so when we sledded back in, I immediately went there and was sure that someone would have visited before. It was very prominent. And there was this note, and then a much longer note inside of it, in a cylinder right inside the cairn. Pulled that out. And this is great. It says, this vessel that came by boat is deposited here this 15th day of August, 1882 by its subscriber who left Fort Conger, just not far away, August the 1st, with a few men of the U.S. Army and the steam launch Lady Greeley. And I love the last bit, for the purposes of reaching this vicinity, etc. Can you imagine applying for an NSF grant and going, I want to go there for the purposes of reaching this vicinity, etc. It was just great. And then Greeley's long note had all his weather records, and it was after they had been there for several years, because he was there for 3 years. And he said, I'm going to put photographic plates in with my note. And I went and I looked and I got the note and I thought, there are no photographic plates. And I thought, oh, this is fabulous, because how many of us suffer from absent-mindedness, or we're multitasking and we can't, and I like to imagine as Greeley in his little cabin with a clock, a pendulum top just languidly ticking away in the background. He's got his pen out and dipping into the inkwell and he's scribing this, and oh yes, I'll put in the photographic plates. And then somebody yells, hey, Adolphus, what are we having for dinner? And he gets distracted for a minute and then he forgets, and the photographic notes are still on his desk, and Lockwood has already hit the trail. So I think there's hope yet for all of us. So get into some of the science. So what have I been working on? And that's really the reconstruction of the northern part of the ice sheets that covered Canada. And when I started in the 1960s, we really didn't have much of an idea of any of these ice sheets, and they had no topography at all. And what you can see now is a lot of ornamentation itself already 20, 40 years old since this was done. But just to give you a sense, this is a Laurentide ice sheet, and this is what will become the Intuition ice sheet. A lot of the dark blue is, just think of it as the ridge, the crest of the ice sheet, the highest point on the ice sheet from which all ice flows. And these are subsidiaries. And these are based on the geological data. So it wasn't just, the ice sheet wasn't just a big blob of ice. It had divides, it had saddles. The divides grew in some areas and migrated over time. When the ice sheet thinned, the divides moved back. Why is that important? It defines all the dynamics of the ice sheet, because the ice flows from right angles of divides, or when divides intercept and there's convergent flow, they set up ice streams. All kinds of important things to knowing what that ice sheet was doing. And this is all based on evidence at the ground, whether the bed forms, land forms, sediments, and so on. That's an important point to make, is that this ice sheet that existed only 18 down to about 10,000 years ago is very much a good analog for the modern day Antarctic ice sheet, especially the West Antarctic ice sheet that is grounded below sea level, so it's a marine-based ice sheet, and it's highly unstable. And when I was in graduate school, certainly there was still talk in the 1960s about the possible disintegration of the West Antarctic ice sheet as it thinned and became buoyant and detached. East Antarctic ice sheet is grounded pretty much above sea level and has much greater resistance and stability. Many aspects of this ice sheet were grounded below sea level. Some of them grounded below sea level. Here, the water depth below there is 1,000 meters in places, so 3,000 feet. The same thing in Hudson Bay. So this understanding this does speak to understanding of the modern ice sheet. There's the Greenland ice sheet. Green is where it's above sea level, the bedrock, and everywhere else in blue, most of Western Antarctica, it's grounded below sea level. And I'll talk about these. The floating margins of this marine-based ice sheet are called ice shelves, and they're very important for producing back pressure, grounding or restraining the outflow of ice from these big ice sheets. And as these have been in the news recently to break up, with the breakup of this, the back pressure is reduced, and many of the big ice streams within it accelerate into the ocean. And this is the wild card, I think, for sea level in this century. So we know a lot about glaciers, and they had an enormous role to play in the past. And because of their size, they removed large volumes of water from the ocean. So all the light color here is exposed continental shelf. So obviously we had a land bridge, the Bering Land Bridge, joining Russia to Alaska, separating the Pacific and the Arctic Ocean. And I'll talk about the re-submergence of that in a little while. But this shows just a plot of sea level through time. This is 5,000 years ago back to 25,000. Here's modern sea level, go down to 50, 100. And during full glacial time, the ice sheets were large enough to lower sea level, say 130 meters, exposing this land bridge. And the other thing that ice sheets did in the areas in which the ice actually physically covered the land was to load the crust. So ice sheets, a 3,000 meter thick ice sheet, would depress the crust underneath it by about a third of its thickness. So imagine the ice, the crust, the land surface going down a kilometer, and at depth the mantle is ductile, it's mobile, it flows out to the margin, and beyond the margin quite a distance you have these bulges, these four bulges. So the ice sheets have an enormous influence on the crust. That deflection, let's call it 1,000 meters, 3,000 feet from the load of the ice sheet, and then we remove that ice sheet, and literally over the span of 30,000 years, the crust returns to where it is today. That's vastly orders of magnitude greater than any tectonic activity. The Himalayas go up a meter for 1,000 years, that's a big deal. There are places in Canada that were going up at the moment of deglaciation 30 meters a century. So this is a really important process. And how do you visualize it? I think I was talking this morning, and I think you could think of it as literally ice sheets doing CPR on the Earth's crust. In geological terms, that's how rapid it is. It's pushing it down, lifting back up, pushing it down, lifting back up. And when you do CPR correctly, apparently, you break ribs. And I think that's the ice sheet can reactivate fault systems. And I think it's useful to think of those kind of terms because it allows us to break down a lot of the ways we look at the landscape evolution, because I think that geophysical response of ice sheets is doing a lot to explain the modern day physiography of Arctic Canada that is still relegated to tectonic processes tens of millions of years ago. And I think the ice sheets have played a much more dynamic role, and the evolution of the landscape is much younger than we thought about it. So what have I done in my work? My PhD was based on northern Ellesmere Island. We didn't know what these ice sheets really looked like. They were sort of blobs without really prominent boundaries. I worked up in the very top end, and this is what's called the Inuitian ice sheet. So this little part here is blown up a little bigger, and then I carry this area into this map. So this ice sheet really didn't exist prior to my PhD, and it's joined to the Laurentide ice sheet to the south. That's the northern end of it there, and it connects in the channel between Greenland and Ellesmere with the Greenland ice sheet, suitably in green over here. And again, we don't have to go into all this detail, but there's a lot of lines drawn on here, and these again are the highest points on the ice sheet, and that geometry dictates areas of convergent ice flow, because ice flows from the divide to the margin. And where you get convergent flow, you get rapidly flowing rivers of ice or ice streams. And these are beautifully marked in this area because there's granite over here, igneous rock, big red hamburger looking igneous rock. All of this is sedimentary rock in this area, and that granite is carried in a stream, a ribbon of rocks that all run out for 800 kilometers, over 500 miles to the margin. So we've done a lot of work. This has taken a lot of surveying, a lot of mapping, and literally about 40 years. And so what do we find as a result of that? What does that ice sheet look like in terms of what was its influence on other things other than moving rocks around and influencing the shape of the landscape? This is like this thumbprint. That's what it's going to look like from the back. Hard to read. These are contour lines. Most are familiar with those. And the contours go from 0 and then up to 10, 20. The thumbprint in the middle, the contour is up to 130 meters. That's the height of the shoreline that was formed when the ice sheet melted away 8,000 years ago. And so that shoreline, like any shoreline, was horizontal. And in European terms, it would talk about the shoreline being de-leveled, being differentially uplifted. So this is how much that shoreline, 8,000 years old, has emerged out of the sea. So if you were sitting in a deck chair over here 8,000 years ago, and your feet were at high tide, they'd still be at high tide today. Zero change. But if you were over here and you were fishing by side the shore and you cast in and fell asleep and woke up 8,000 years later, you would be 20 kilometers inland and you would be over by almost 500 feet above sea level, standing on your beach. So what does that mean? That area of very substantial rise in this 8,000-year-old shoreline, that's the fingerprint of the ice sheet center. And I remember I had finished these isobases, and it's actually, the modern-day ice sheets are all in white around in the mountains. The greatest uplift was over a basin into which all the ice flowed. And I was sitting there looking at these isobases thinking, oh, they look okay. And literally over on the screen, an email came in from David Bromwich at Bird Polar Research Institute. He said, hey, John, look at this. I've just run my climate model, and here's the axis of precipitation during the last glaciation over the high Arctic. And the big controversy has always been, well, how do you build an ice sheet up there? It's so dry, okay? And so we turned around and think, oh, he's run this model, and he's going, this wasn't dry. The jet stream coming across from the west into North America split around the larger Laurentide ice sheet to the south. And one limb that he had in his model went directly over the axis of my uplift center. He went, here's where the precipitation was 5,000% greater than it is today. And I'm looking at the map and I'm writing back to David Bromwich and says, you've been looking at my isobases, this is where the axis of the ice sheet was. So that was really interesting. The other thing, think of that sea level being 140 meters higher than it is today. The water depth in all these channels was much deeper. Today, these channels are so shallow, only cold Arctic water migrates southeastward into Baffin Bay. When the water was so much deeper, because of that depression of the land that hadn't yet risen again, the ocean was in these channels well over 300 meters deep. And as a result, Atlantic water could move through the archipelago underneath the surface water. As uplift continued up to the present day, that water depth shallowed, and that precluded any more transport of Atlantic water through the archipelago, and it was replaced by just cold surface water today. And that has a huge number of paleo-environmental implications. Bowhead whales, at the time these channels were deeper, and the Laurentide ice sheet was pumping out so much meltwater, the surface of the ocean here was higher. It was less dense, has to have the same mass. If it's less dense, has to be greater volume. So the sea surface here was actually elevated relative to the Arctic Ocean. And so the flow of water was out of the archipelago. So the channels are deeper, this favorable flow of water was out of the archipelago. This area was swept free of sea ice, all this blue. During deglaciation, up here further north, all that brown is sea ice. Because of the open water, bowhead whales came in with the greatest abundance right along the retreating ice margin. It was extremely favorable to the bowheads. The Atlantic stock and the Pacific stock were entirely intermingling at that time, 8,500, 5,000 years old. Then the ice sheet retreats over the drainage divide. Now it's in the Hudson Bay off this map. This flow is reversed, and the modern sea ice transport and the surface currents come in from the northwest to the southeast. They choke these channels in the summer with sea ice, and now the Atlantic bowhead can get into about here, Pacific bowhead into about here, and now from the last 8,500 years up until climate change has reversed it, the Atlantic and the bowhead stocks were separate. This is based on hundreds of radiocarbon dates on bowhead remains on raised beaches, the very process I described a moment ago. Here's a graduate student standing beside the skeleton of a bowhead whale. He's up at about 300 feet above sea level, and his coast is 5 kilometers away. And on flights of beaches down towards modern sea level, the history of the bowhead whale is laid out in front of you on thousands of kilometers of coastline. And this is the excavation of a bowhead skull, and we're excavating the ear bone for radiocarbon dating. So everything is interconnected. I think that's, I hope, a message that you start to see. So, you know, we're working on ice sheets. We made them bigger. They cover all this area. I was sitting at a conference, and the Europeans come in and they go, look at the mapping of the seafloor. You know, it's scoured. Seafloor, the Arctic Ocean, there's the North Pole, Lomonosov Ridge, the Canada Basin, the Eurasian Basin, 4,000 meters of water, but in places, even at 1,000 meters, 3,000 feet of water, there are lineations on the floor that show a coherent abrasion of the ocean floor by blocks of ice. Ice sheet, possibly. An ice sheet on the Arctic Ocean was suggested by John Mercer back in the 1950s. So this is the person who first told me this at a meeting at the University of Massachusetts. I think everybody thought that, you know, what have you been drinking? Because this is just was unheard of. And I think that's the nature of science. You break through a paradigm and you're immediately skeptical. And so no one really thought, hey, these got to be iceberg scours. That's one thing. But no, as more and more work has been done, they're now finding coherent masses of ice that we're scouring 300, 400, 900 meters of water. And so I think that was really interesting, because the Europeans would say, well, that was in marine isotope stage 6. What does that mean? We're in interglacial. The last glacial had a preceding interglacial, Sangamon. Before that was stage 6, much older glaciation. So we turn around and go, hey, we have all the ice you need during the last glaciation. We have all the ice you need 15,000 years ago, 15,000 years ago, to scour the ocean floor. And I can't resist saying this because, yes, we're speaking to questions, answering things for other people, I think, in the process. But here's the Lomonosov Bridge. The Russians put down the titanium flag, part of the law of the sea. They claimed the Lomonosov Bridge, of course. And I was at a meeting in Ottawa, and the U.S. Polar Commission and the Canadian Polar Commission were meeting, and I got up and talked about future polar science, and I looked at the audience, and especially the American group, and I said, well, you guys get concerned about the fact that the Russians have put a titanium flag down on the Lomonosov Bridge, because Canadians all respond like, oh my goodness, they're going to claim it, and what are we going to do? And I looked at the audience and said, the titanium flag, you can buy one like that at Walmart for like $2.75. Canada has put down 2 twin otters down on the floor of the Lomonosov Ridge. They've gone through the sea ice doing sea ice exploration. So I said, if we really need to have proof and validity of who owns the Lomonosov Bridge, we've got the twin otters. And I talked to a pilot recently. He said, no, he says, not 2, we've got 5 down there now. So there's got to be fun in science as well. But I keep it rolling. So one of the things that we also studied, not only the ice sheets were large during last glaciation, I mentioned at the beginning There are many characteristics of ice sheets that are former ice sheets that are very instructive analogs for modern ice sheets. So again, the West Antarctic ice sheet, grounded below sea level. The colored bits are floating margins called ice shelves. So here's the grounded ice, here's the land, it's grounded. Come to the margin, you can see the sea going underneath the floating margin. This is all contiguous. And these ice shelves are in the order of 400,000 square kilometers for the Ross and the Longfilchner. But there are many others that have been in the news lately, the Larsen Sea and others that are breaking up. Again, why are these important? These guys are like you and I pushing against each other shoulder to shoulder. This offers back stress to the grounded ice and conserves the evacuation of ice from the interior of the thick grounded ice into the ocean. If you're leaning against me and I'm the interior ice and you step out of the way, I go forward. So many of these ice shelves are fed by rapidly moving rivers of ice streams. And these ice streams are known to accelerate six-fold when you remove these ice shelves. Even little bits of them like that. All the feeding ice streams accelerate. These ice streams are 80, 100 kilometers wide. They're a kilometer thick. And so they're moving tens of cubic kilometers a day into the ocean. So the whole question is, how stable is the West Antarctic ice sheet? And here's a good example of one of those ice shelves. And clearly the evacuation of ice into the ocean, the removal of the ice shelf, it's floating, so it's displacing its own mass, but it's the grounded ice that's going to raise sea level. And that's North New Orleans after Katrina, so the whole idea of storm surge is nothing new to you guys along this coast. What's sea level going to do this century? How many hundreds of millions of people do we have within 2 meters of sea level? You know, we think of how many people are migrating into Europe right now from Syria or anywhere, the impoverished, South America. A train of people moving towards the southern United States and Mexico right now. They're desperate, desperate people. And I think we can't ignore the fact that climate change is obviously going to be an enormous instrument in terms of migrations of people, climate refugees. And I gave a talk in Singapore last year, and I could put North America on this map, it would be the same thing. This is cities that are vulnerable to sea level rise, and the largest cities are more than 1 million, Calcutta, and obviously Singapore itself, and Seoul, Tokyo, and we can do the same thing here, Boston, New York, Miami, you know, there's Vancouver, Halifax. So, you know, this is no time to doze off, and the paper by DeConto out of the UMass, I think they've emphasized that the instability of the ice shelves are the sleeping giant for sea level rise this century. The predictions are 1 to 3 feet, but you could double that if those ice shelves become progressively more unstable. We have no way of really modeling that effectively. So why I emphasize that is during the deglaciation of the western ice sheet, I came across a remarkable record of a former ice shelf. If we flew over, just to give you scale, we could be in a satellite right now. We could fly over this, and we'd be looking down at Banks Island. How big is Banks Island? I could pull that off and put Iceland here. And you know, most Canadians wouldn't know the difference. This is a big place. And this ice shelf runs for 1,000 kilometers. It marks the coastline. So this would happen, the ice sheet pulled back during deglaciation, and then suddenly it re-advanced. And the grounded margin is the lighter blue, and it floated an ice shelf, continuous feeding from this grounded ice, enormous ice shelf. And it runs for 1,000 kilometers, and it marks like you took highliner to the coastline. It just smeared marine sediment, because as this floating margin advanced out and spread out, it basically tucked onto every coastline that was available, even went into bays and inlets. And it ran up on the shore because the sea level was higher at the time it advanced, and it spread marine sediments all along this coastline. Again, it's like highliner all the way around. There's no other example on the planet that is as good. Nowhere. And we could walk along it, and the edge would be as sharp as the edge of this stage. You'd be on it or you'd be off it. That's how prominent it is, and it's continuous. So this great swath of sediment contains marine shells, and here's an example of these beautiful moraines. These ice masses are floating over hundreds of thousands of meters of water. Because it's floating, the glacier's dead flat. These are moraines left by it that contain marine shells. When we flew by these for tens of kilometers, these moraines are so low and so flat, I thought these were shorelines, but they didn't look like shorelines. I've looked at shorelines forever. And I suddenly realized this is an ice sheet forging a shoreline. The ice sheet actually is attempting to make what looks like it was floating, and it's fabulous forgery. It's a magnificently beautiful landform that really nobody's ever described. And we went along and dated these things, and what's interesting is the ice that moved forward to produce it scoured shells out of the ocean where it was grounded and plastered them way up the side of a valley. Up here, they were plastered all around. This ice shelf formed and advanced 400 kilometers in less than a human lifetime. The radiocarbon dates on the shells up here are indistinguishable from the shells down here. It formed in less than a human lifetime, lasted 400 years, and disappeared in less than a human lifetime. So Reed Bryson, climatologist from University of Wisconsin, used to say what has happened can happen. So it's an analog for the disintegration of the modern ice shelf, and it's at a scale vastly greater than the breakup of the Larsen. This was 100,000 square kilometers. So it really rivals the biggest ones. I wanted to talk about a few, oh my goodness, things. Surprises. Shell coming out of Bering Strait, found it at 3 a.m. It's a shell that shows that Bering Strait went under 3,000 years before we normally thought Bering Strait went under. I've been following the footsteps of explorers. This is Nansen. He sailed in the Fram across the Arctic Ocean. And you can see that his boat was put into the ocean. He floated across. He believed there was a current in the Arctic Ocean. Everybody contradicted him. He built the Fram. It drifted across to Norway. He proved that there was this amazing current. Nobody's really done much with that since. And what we did was driftwood all around the Arctic Ocean basin. And we found that the driftwood that came from Russia, sometimes it went to Russia, or from Russia to the European Arctic. Sometimes the driftwood comes into the Canadian Arctic. Sometimes it's weakly split. And the point being that the driftwood that we used to radiocarbon date our ray shorelines actually became analogs for as paleobuoys. Driftwood can't get across from here to there without sinking, because it takes 3 years. So it has to be embedded in sea ice. So where you find driftwood, that's where the current went, laden with driftwood. And so driftwood then became a marker and showed that the transpolar drift that Nansen found actually splits and changes direction over timescales of centuries. And it's being driven by atmospheric circulation, so it becomes a proxy over the last 10,000 years reconstructing atmospheric pressure. I'm whipping through a few things here. I want to get through this, and I wait for the shepherd's crook to drag me off the stage. This photograph is of the Ellesmere Island ice shelves, and this is another major change that we have documented. This ice shelf dates 5,000 years old. This is about 3 football fields from ridge to ridge, and these are shallow meltwater ponds. This is the oldest sea ice in the Northern Hemisphere. And this photograph I took in 1978, 1980, and everything in this photograph today is gone. How, and somebody just said to me, wow, John, this is a terrible diagram, but here's climate change, 1880, 2000, this is the tropics. Temperature has risen maybe a degree centigrade or so. The Arctic has gone up 2 or 3 degrees. That's Arctic amplification. And I was saying to Ray Bradley, and we were up there when the climate was much more like what it was like for the explorers. And as a result, I think we can really relate to what we saw then in relationship to what we're seeing today. We were up there, our career span Arctic amplification. So we're looking at this meltdown of sea ice and global change. And I don't need to hammer this point. Sea ice has been reducing in areal extent. Here it is declining over the last 20, 30 years. Here we are in 2018. Here's the long-term average. We've lost huge amounts of sea ice. And not only have we lost areal extent, we're exposing the ocean to absorbing more solar radiation, so it's heating up even more. We're also losing the old ice. This is from 1984 to 2017. The old gnarly multi-year sea ice is being progressively removed and it's not being replaced. And the thinner, weaker first-year ice is taking over. And I thought this is an incredibly important diagram. 1979, like the arms of a clock going to 1990, 2000, up to 2010. All these lines simply show different colors of the year, different months of the year. This is the most extensive sea ice. Zero sea ice is in the middle, most extensive up here. If you follow the most extensive sea ice in 1979 and follow it around, you can see you land up thousands of millions of square kilometers shorter than where you started. That's the least sea ice at the end of the summer melt. You used to have this much. You go around from 1979 to 2010. It's this spiral of death where at the end of the summer we're approaching sea ice free Arctic Ocean. And these old sea ice shelves that I was describing, they were traveled by the explorers in the late 1800s. They traveled all along this coastline. This is ice that was in place and never melted away. They described it as a rolling prairie landscape. It was being held against the shore by the pack ice. Now that we're getting rid of the pack ice, that whole ice shelf system that used to go out to the dotted line has disappeared. What's left is not even the black remnants. They were there in about 2000. Every one of these is gone except this one. So they're disappearing. You can say, well, okay, how often do they form? We looked at driftwood coming into the fjords. Driftwood came in at 9,000, 6,000, all the way down to 5,000. Then no more driftwood gone into these fjords. That's when the ice shelves formed. And the ice shelves have blocked out driftwood to the last decade. And for the first time in 5,000 years, it's broken up and disappeared. And so we're about to lose these. And I talked to them that there are California redwoods, there are Egyptian pyramids, and most Canadians wouldn't even know they've disappeared. Glaciers are thinning. This is a map of the Canadian Arctic Islands. Tomorrow, Catherine Lafarge will talk about changes in ice margins. In the 1960s, it was the heyday of ice. It was accumulating. It buried this hut. And then snow continued to thicken on these ice caps through the early 70s, built this hut. Then ice continued to build. In 2004, built that hut. So over those 40 years, the glacier thickened all the way up to here. And then within literally a decade, the whole thing thinned with the global warming. And friends that were living up here, it was like the Tower of Pisa was like leaning in the wind. In 2013, it all fell. There's a great visual image. I'm not going to go into permafrost, but all I can tell you is that there's buried ice on Banks Island that is from the Laurentide ice sheet. It's 13,000 years old. It's been insulated from summer melt by a layer of debris not thicker than this stage. And this ice now is no longer protected by this active layer, the summer thawed layer, because the depth of thaw now is going right through it into the ice. And vast areas of this landscape is falling apart as ice that has been happy, as I say, for 13,000 years is now melting out. Those sediments that you can see from the air going into lakes and rivers, coastlines, and has enormous implications if you're dependent upon fishing in these lakes. Grizzly bears are moving up into the Arctic islands. There's a grizzly bear that normally on the mainland, they're now common up here, and polar grizzlies have been described. And we found one and did the genetic work on it, and it's from Pawatuck. It was way up on Melville Island. Huge changes going on. What if the explorers came back? That's what they were up against. And this is Greeley, the book I mentioned, Reed Gutteridge. I was in the same area where McClure's ship was crushed and they were rescued after 2 years, scurvy setting in. I looked out from where he was stuck in 2010, and I could look at her, I could have been at Cape Cod. As far as I could see, there wasn't a scrap of ice in any direction. He came, ironically, looking for the open polar sea, victimized and crushed in sea ice. 100 years later, there's the open polar sea. And I went to a conference in Tokyo in February. We're looking at shipping all over the Arctic now, especially the northern sea route, and the Russians, and certainly the Koreans and the Chinese. They're making icebreakers like popcorn, and they're moving all kinds of natural gas and all kinds of stuff between Russia and Asia that completely bypasses now the Straits of Malaga and the Indian Ocean, the Suez Canal, etc. So huge implications for the use of this environment. And only by saying that all the science, all these international meetings, I think all through this, it's like creating a sense of the Arctic like a movie in time lapse. And I think that each frame is a lake core, an ocean core, or it's a shoreline. All these things fit together. And yet, I think the really missing ingredient that came together for me forcefully towards the end of my career was the interaction with communities and traditional knowledge and relationship and friendship. And that has been hugely transformative. And it makes me think, I wish I knew earlier in my career how vitally important those human relationships were and how enriching they were. And we've had a tradition where we separate science from human communities or human relationships. It's almost like, I don't know if you ever had the advertisements of Man from Glad with his garbage bags all dressed in white, everything neat and tidy and contained. That was science. It's not that way anymore. We're looking at human migration. We're looking at climate change. We're looking at environmental adaptations. We're looking at the needs of people. And this is like telling us that there's a deeper and more meaningful relationship in everything that we do. And if you're not finding that in your science, you're not doing your science meaningfully. And this is, I'm almost at the end there, Bernard. But this was I went and talked to grade 2 students in Whitehorse. My grandson was in the class, and I showed them pictures of this iceberg in Ekalugad Fjord on Baffin Island, taken in 1966. And I told the kids, draw me a picture of the Arctic. They didn't draw the picture of the Arctic an hour after I left, or half an hour after. They drew it the next day. And this little girl, Aniela, drew the iceberg and me standing there, and I was just blown away. And I sort of thought, if you don't believe in evolution, talk to an 11-year-old, talk to an 8-year-old. They're just like on fire with creativity. And I end with 2 quotes, because a lot of it is about doom and gloom, and I didn't mean in any way to suggest that. One of the quotes is from Teale de Chardin, one of my heroes, Jesuit priest, early 20th centuries. He says, the age of nations is past. The task now before us is to build the earth, to transform the earth. I think Teale would rather hear the word spoken. And then I remember somebody saying the other day, I was on the ship giving a lecture, and they said, oh, it sounds so dreary. And I said, you know, I quoted from Bob Dylan, your latest Nobel poet. And it's from All Along the Watchtower, and he basically says about doom and gloom and the businessmen coming and going. He says, no reason to get excited, the thief he kindly spoke. There are many here among us who feel that life is but a joke. But you and I, we've been through that, and this is not our fate. So let us not talk falsely now. The hour is getting late. Thank you.
We have time for some questions. John?
Well, so you alluded to it at the end, but I'd like to hear a little bit more about how those indigenous communities are how they're being affected by all this.
Yeah, so the Supreme Court of Canada has basically passed the law that Inuit and Aboriginal people, First Nations, have on treaty land, and also land being traditionally used beyond treaty land. They have the absolute veto on economic development. So talk about suddenly putting smelling salts under the noses of everyone who wants to do science. If you do science in Northern Canada, you have to put in, scientific licensing and so on. And I think it's more that we don't look at it as, a burdensome requirement. It's an opportunity to open new doors. And I've been traveling. When I went about a year ago, I traveled with a young Inuk woman from Labrador, and we were kind of a tag team on talks like this in Seoul and Tokyo and Singapore. And I think what I can say is that there's just a real opening in science and in the whole culture of research and the culture of northern communities in realizing that this is a partnership, and if it's not a partnership, it's not going anywhere. And it's not so much a mandatory partnership. I think it's an enriching interchange of cultures and different ways of knowing. And it's also an enrichment in terms of what does it mean to do research? I think we really have to start asking, and you made very well aware of this, deeper questions about what does my research mean and who does it make me become? And I was saying to somebody, when you come back from the Arctic and you've done your work and you've interacted with communities, unless you walk down the street carrying that renewal inside you right here and now in everything you do, then you've missed the deeper meaning of what you're doing. And I think that I would ask that, in Canada, I would say let the Indigenous cultures become much more ingrained and let their wisdom and their understanding, their way of looking at things, infuse the modern Southern culture. And that would make Canada a much more interesting, diverse place. So I don't know if that answers you, but they have much more autonomy. The pipeline from Alberta to British Columbia right now is held up for one reason alone. The First Nations of British Columbia don't want it. A lot of them. Some want it, some don't. So it's a real muddle. But if you want to look at where the rubber hits the road, they have the strength to block things.
Do you think that will continue when gold is found under the ice in northern Canada for major companies? I expect scientists like you you won't be able to do the science without collaborating with people. Do you think large for-profit companies will be held to the same standard?
Yeah, and then that's an interesting question, because on Baffin Island right now, there is a diamond mine set to go in on Meta Incognita Peninsula on the south end. They'll dig a big hole. And yeah, I think, as I would say for myself as a scientist in Southern Canadian, I would go, oh, don't do that. When I was up there in '65, there was a big iron ore company that the Chinese are working on. So I think you're right. We're not there yet in terms of really moving forward to a progressive environmental relationship. Or they're up there, they've got suicide rates coming out of their ears. They have unemployment coming out of their ears. And they can turn around and say, we're not a museum piece. Obviously, we're a living, dynamic culture. And if we've decided that this is one way into a more productive and a more harmonious and a more healthy society, you did it. How many third world countries are saying that to the West right now? You did it, and so, I think we've got to, swallow some pride and have the humility to turn around and go, okay, we'll journey with you, but let me at least have my voice to tell you why, maybe what's about to happen isn't a good thing. Yeah.
Are there any proposed changes to international shipping rules to change the requirements of vessels going through the Northern?
Oh, that's a good question. The governance conference, as a Canadian, I sat like where you are, listening to the Chinese get up and give the Arctic policy of China. I listened to Russians get up and speak about how respectful they were of indigenous cultures. There was something behind that voice, like the Wizard of Oz. It wasn't convincing. And when I think of the Taimyr Peninsula and the big natural gas going in, LNG plants, are they going to stop production in that area because of indigenous concerns? Zero chance. And I just felt, listening to it, I was more horrified by the magnitude of shipping that's going that way. They're talking 24/7 shipping. through the northern sea route. And you've got Russia basically holding the valve on whether you can go or not. And so I think that the law of the sea, there's a lot of talk. There's a lot of talk. But how much of those ships are, really going to be following the environmental scrutiny, environmental sensitivity that we would really hopefully would be doing. But, I think we have to be vigilant. We have to work as a world community and just go, if we're going to do this, we got to do it right. Russians cored Lake Vostok, they filled it with diesel fuel. We're going to look for early life. Are we in a race to see who gets to the bottom first and put some diesel into the lake, or are we wanting to do this as a collaboration and do it carefully? And that's really where we're at, and the greed is, yeah, it's the gorilla we have to body slam.
Any more questions?